Ready to share?
Yes.
Awesome. Okay, so chemical reactivity. Kia ora koutou, and welcome back if you've been to one of the earlier Level 2 Chemistry webinars. We've got the wonderful Sujata with us, and Sujata is going to run us through chemical reactivity. If you've got any questions, pop them in chat, and I'll either ask Sujata those as we're going, or I'll collate some questions and ask Sujata those at the end. So thank you once again, Sujata. Over to you.
Thank you, Doug. Welcome back, students. And sorry, yeah, I'll share my screen. Okay. As I talked to you through my last presentation with organic chemistry, this is the websites which I would suggest you all go through, and it's easy. The GSZ science class can be, there are a lot of things, but what mainly I would suggest is go through that excellence questions, and that helps you. No Brain Too Small gives you an overview of the topic. It gives you flashcards for you to remember. And these are the good ones, especially No Brain Too Small for your last minute revisions. So chemical reactivity, it's again a very easy topic, extremely easy topic, because part of it you have studied last year as a part of your acids and bases topic, looking at reactions and the factors that affect reactions. The only addition this year is you are looking at, if you in your year 11 exams, in your year 11 you learned about reaction going one way. This year you have the reactions can go both forward and backward, so you call it a continuous reaction, where the reactants turn into products, and the products then still continue to break down the bonds to become reactants, and it's an ongoing reaction. So this, along with that, you learned about pH, you learned about concentration, and here we are looking more into the calculations. And this is simple one-step calculations, which with a graphic calculator or with a normal calculator, you have the log buttons, which is 10 to the power logs. So you have no difficulty in that. So going back now, your first questions, normally not the first question. When I say first question, it can be your questions mainly. There are, you know that there are only three main questions. Your questions, one of them would be on the reaction factors. That is whether you're talking about concentration, temperature, surface area, and catalyst. Last year in your exams, you never had a question. In your year 11, you never had a question of factors, in the factors relating to catalyst. This year, you definitely have them. You can be asked about that. And what you're looking at catalyst, the same thing. It lowers the activation energy needed. Here, when you're looking at what you have to state is your collision theory, which you know from last year, revise it. So when you're talking about the collision theory, you have to talk about the number of particles. You have to look at the orientation, which is key for a collision to take place. Also, in what state, that is, what are the things taking part in the reaction? What is the factors affecting them? Are the temperature being increased or decreased? Or is it the concentration that is increased or decreased? Or is it the surface area? In typical in surface area, where they're going from chunks to being a powdered form, what is it? What you're occupying. Then link the factor to the collision theory. So if the temperature is increased or the concentration is increased, what happens to it and what happens to successful. Now here, this is very, very important. You are linking your successful collisions per unit of time. So what happens as the time goes by? Does the number of collisions or the frequency of collision increase? Is it successful collisions? And other thing you need to talk about is per unit volume. So the volume, if the volume hasn't changed, volume will not change. So is the number of collisions per unit time, per unit volume increased or decreased depending on one of your factors? Summarize your reaction, and now you say the rate of reaction has increased and therefore the time taken for the reaction has reduced. Please do not confuse your rate of reaction to the time taken. But if the rate of reaction has increased, the time taken for the reaction has reduced, or the other way around, if the rate of reaction has decreased, the time taken for the reaction to complete has increased. And remembering that when a reaction finishes, the amount of product, whether it is a fast reaction or a slow reaction, the amount of product formed will be the same because there were the same number of reactants which form the product. So there will not be any change in the product's form except for the time taken will increase or decrease. Now here I have drawn the reactions. So you see if the surface area is one of the factor, the surface area, if the surface area has increased, it increases the frequency of collision and increase reaction rate. If the concentration has increased, you know that the number of particles available for reaction is more, and therefore there is an increase in the number of collisions per unit volume and per unit time, hence an increased rate of reaction. Now, if the temperature has increased, what happens? The energy of the particles, what you mean by the energy is the kinetic energy of the particles has increased, and therefore the frequency of collision per unit volume per unit time has increased, and which results in an increased reaction. Catalyst, what it does is lowers the activation energy. That means the minimum energy what is needed for a reaction to take place has been lowered. Therefore, there can be the percentage of successful collisions can increase, thus leading to an increased reaction rate. Yeah, looking at this again. So factors increased have again look at it, how I've written if it is the concentration has increased. More particles in a given area, therefore more chance of colliding. If the concentration hasn't increased, but more successful as more frequent collisions. Surface area, if it is yes, then you have more particles in a given area, therefore more chance of colliding. If the surface area is not increased, does it increase the percentage of successful collision? No, but more successful collisions per unit time as more frequent collisions. If there is none, the surface area hasn't increased. The same thing. So this is the chart you can follow through, and has they collided in the correct orientation, and has have you decreased the activation energy or increase the activation energy? The catalyst talks to you about that. So links the answers to the increase or decrease in the reaction rate. So this is one of them. Now coming to the next part of your writing. Now this is the part where I was talking to you about equilibrium. Now equilibrium is nothing but a system stays in equilibrium unless, now this is exactly like your level 2 mechanics where we talk about Newton's first law, where uh, an object continues to be in a state of rest or uniform motion. Here we are talking about chemistry, we are talking about reactions, and what we say of equilibrium is when the concentration of the products is equal to the concentration of the reactants. And that's when we say if the amounts are exactly same, we say the reaction is in equilibrium. Unless you have made any changes And the changes can be in terms of pressure, concentration, or temperature. Now, if you are increasing, the, oh, sorry, I missed. Yeah. If there is an increase, then what happens is that if any of them there is an increase in the pressure, concentration, then what happens is that the rate of the forward reaction, that is from the reactants to the product, increases. If there is a change in if it is the other way around, if the pressure is decreased or concentration is decreased, your reverse reaction, that is the products getting broken down into the reactants, increases. But after some time, it will again readjust to get into an equilibrium position. This condition only changes if there is a change in temperature. If there is a change in temperature, either increase or decrease, there will be a permanent shift in the equilibrium. And this you have to keep in mind. Hence, I repeat again. Now, while writing an equilibrium question, what does an equilibrium mean? An equilibrium means that the concentration of the reactants is equal to the concentration of the products. So that means that reaction is in equilibrium. When we say a system, we consider one full reaction, that entire reaction has a system. How can you change? Just similar to the factors we talked about, the factors that can change your equilibrium is pressure, concentration, and temperature. So normally when we talk about any reaction in a system, we refer to the temperature at 25 degrees Celsius and the atmospheric pressure of 1 atmospheric pressure. That is the standard taken. But if you change the pressure or if you change the concentration, what happens is that if you're increasing the pressure or increasing the concentration, the rate at which your reaction from the reactant to product happens, it increases. But remember, that is only for a short time, and then it will readjust itself so that the forward reaction and the reverse reaction come into a balance. It is only for a short time this happens. Again, if concentration also changes, increases or decreases, the same thing happens, but it is for a very, very short time till the system can readjust, rebalance them. But if you are changing the temperature, there is a permanent shift in the equilibrium. Now, how do I make you understand? It is the classic example. If you are taking that we fill the pressure the pressure is always given for our tires. What do we say? Come summer, we reduce the pressure in the tire so that the air can expand, so that you will have to give them room for that to, and come winter, you can do it to a full pressure, whatever it is stated on your tires. The same thing is what we apply in chemistry. So you have to remember that when we are talking about a system, we are talking about a reaction happening. Now, what does Kc stand for? Kc is your equilibrium constant, and this is the concentration of your products. So if you have more than one product, it is the concentration of your product. And it is a power to? The power is the number of moles which is there. It is the concentration of your products divided by the concentration of your reactants, where your exponential stands for the number of moles. I repeat it once again. Kc stands for the equilibrium constant, and the equilibrium constant is calculated by calculating the concentration of your products over the concentration of your reactants. And what you see here as your exponential is your number of moles.
Now, just on that note, Sujata, there's a question from Haley. How do you know whether to use a normal arrow, like a single direction arrow, or equilibrium arrows in a reaction?
Okay, it will be stated for you in the reaction. It will be very well stated for you if it is an ongoing reaction or the reaction goes one way. So if it is they say it gives you the end product is that the reaction is finished, it's a single arrow. If they say the reaction is ongoing, it is a double arrow. Have I clarified the question?
I think you have, yeah. Thanks very much, Sujata. And Haley, if you've got any further questions on that, just fire them in chat. It was lovely to see the discussion on that one. Thanks, Sujata.
No worries. Now look at the questions. How do you write the equilibrium constant? The equation will be given to you, so you need to use that to write your full equations. Then you calculate you will be given, now either you might be given the equilibrium constant, or you might be asked to find the equilibrium constant. So in that way, what you do is you substitute in your equation. So this equation, either you can be given equilibrium constant and finding the concentration of one of your products, or finding one of your reactant concentration. It can be either one. Or sometimes you are given the concentration and the number of moles, and you have to calculate your equilibrium constant. Either one will be given to you. But in each way, you need to write it in your answers. You need to follow this procedure. You need to write the equation. Let me see if I have I'll go through, and then once I've gone through that, I will tell you if I can find an equation, I will show you how to write it. And remembering that your answers should be in 3 significant figures. Now, chemistry requires you to write all your answers of calculation in 3 significant figures. It is not 3 decimal places, but 3 significant figures. And your final answer, that is the concentration, the equilibrium constant. If they are asking you to find the equilibrium constant, remember it is a constant and does not have a unit. If it is concentration, it has a unit, moles per liter. So, but if you're finding the equilibrium constant, it does not have a unit as it's a constant. Now, one thing in equilibrium constant, which I will show you very shortly. What is the next thing? This is the key thing you have to remember. If the equilibrium, your final answer, is less than 1, then it means there are more reactants than the products. So now, as I was telling you for the equilibrium constant, you can see that the product is, you have the concentration of NO, and it is to the exponential 2 because you have 2 moles of NO. Now, O divided by the concentration of N2, and the power is 1 because it has only 1 mole of N2 with 1 mole of O2. So 1 mole of nitrogen molecule with 1 mole of oxygen molecule. And remember, these numbers are given to you. You don't need to remember it. If your final value is of Kc is more than 1, then it is there are more products compared to more of the reactants. So here you see there are 2 moles of HBr. So the concentration of HBr to the power of 2 divided by the concentration of H2. There is only 1 mole of H2 and 1 mole of, so what is here is 1 each, and that's why we have not put the exponential number. Now, look at the keynote put here. Some questions will ask you to calculate a value using the equilibrium constant and provided concentration. So sometimes you have to calculate Kc, but sometimes you are asked to compare the value of Kc at a particular temperature. So they might give you the Kc at, let's say, 600 degrees Celsius. And they'll say this is that. Now, what will be the Kc at? Maybe at a different temperature, or you have to calculate the Kc at different, and you have to compare the original value to what you have calculated. So if that value indicates the reaction is like they are the same, so if the values both are the same, then it is at equilibrium. Or if they are not same, so if it is more than your original value, then you have more products compared to what was originally there. If the calculation of your constant was less than what was provided to you, then you have more of the reactants compared to the products at that particular temperature. That is what you have to do. Here, this is a classic example. So if I have to write here, I'm writing an equilibrium concentration. Kc is equal to concentration of SO3 to the power of 2 divided by concentration of SO2 to the power of 2, because there are 2 moles, times concentration of O2, and that is 1 because there's only 1 mole of O2. This is what you write as an equilibrium constant expression for this reaction. So, and if I want, I can write here, I can write in bracket 4.32. That's the equation I've written for you. Now, we know from yesterday's class what is an exothermic and what is an endothermic reaction. Exothermic, heat is released in a reaction. Endothermic, heat is supplied for a reaction. Now, what happens? What happens is in an exothermic reaction, if the temperature increases, the equilibrium constant decreases. If the temperature decreases, the equilibrium constant increases. But in an endothermic reaction, if the temperature increases, the equilibrium constant increases. If the temperature decreases, equilibrium constant decreases. Endothermic, it is if one increases, the other increases. But in an exothermic, it's totally opposite. If the temperature increases, the equilibrium constant decreases. And if the temperature decreases, the equilibrium constant. So these are the things you need to write in your answer while answering about equilibrium constant and the effects of temperature. In this equation, see this, delta H is negative 200 kilojoules per mole. So you know that this is an exothermic reaction. And in an exothermic reaction, what you are saying is that the Kc will decrease if the temperature is increasing. The Kc will increase if the temperature is decreasing. So that is the effect of temperature on that particular reaction. Now, this is a reaction, has a following concentration. Now, what you have to do is, so this was to our earlier question. So this is the reaction we have. So I'll write it was 2 SO2 plus O2, giving you, it was, if I'm not mistaken, No, sorry. Yeah. Yeah. So you have to first, what we have done is write the equilibrium constant reaction, which we write Kc is equal to the concentration of your product, the concentration of the product over the power of 2 divided by SO2 to the power of 2 times the concentration of oxygen to the power of 1. So you put, so it is SO3 is 0.250 to the power of 2 divided by point to the power of 2 times 0.1 to the power of 1. It is just 1. I just accidentally put there. You don't need to. If you don't want to, it was just to show you. Yep. Yep. So then you put it in your calculator and you have your power exponential one and calculate it. And what you're doing is that you are taking this answer and comparing with your earlier answer of 4.32. So once you calculate that, so you are comparing with this answer. This was part, if I'm not mistaken, this was a 2015 question. In the year of 2015, this question was asked. So what you're doing is finding out the equilibrium constant given that values and comparing the answer. So if it is a lower, if it is same value, so how do I answer this? If when I calculate this answer, if I'm getting the same value as this, then you can say that the reaction is in equilibrium. If it is less or more, then definitely you go back to your this one. If your Kc is less than your original answer, then there are more reactants compared to the products. If your Kc is more than your original answer of 4.32, then there are more products and obviously it is not in equilibrium in either way. You can only say if the reaction is in equilibrium if your Kc value, what you get here is 4.32, which was given to you in this equation. If it is the same value, then only you say it is in equilibrium. And if it is not, then it is not in equilibrium. Anyone, any questions to this understanding?
Yeah, I don't know if you'll be able to clarify this one for Flynn, but he has some issues when he's using his calculator in this particular reaction with working out the Kc. And it sounds like it might be that does he need brackets around the denominators?
Yeah, so I'll show you how to do that.
Awesome, thank you.
Now, if on my calculator, so my Kc equation would be here. I have shown you it is 0.25 to the power of 2 divided by 0.300 to the power of 2 times 0.100 to the, yeah. So when I'm doing it on my, if you have a graphic calculator or any calculator, what I would suggest is here, double brackets, 0.25 squared divided by 0.300 to the power of 2 times 0.100 double bracket, and you will not make a mistake. This is the easiest way you can do it, so you won't make a mistake. So start with the double bracket has to end, and this is the first one you have. Here times, it won't make a mistake here. So you have your exponential or square button. Now this is square, so it's easier to do the square on your calculator. I don't have an online calculator with me, but yeah, this would be easier. This way you should be able to do it.
Brilliant. Thank you, Sujata. And Flynn, if you've got a calculator in front of you and you want to try that, and let us know if you're having any problems with it after that. Thank you.
So here, this comes to that again, as I told you about, answering the questions about equilibrium in terms of pressure, concentration, temperature. Everything remains the same. Either it is pressure, concentration, temperature, whatever it is, your same description again and again, the same thing. Now, why I'm saying it is just same as what you yesterday when I talked to you about shapes, polarity, and angles. This one, the equilibrium answers follow the same pattern, irrespective of whether it is a pressure, concentration, or temperature. One thing what you have to maintain is if the pressure and the concentration is increased or decreased, whatever it can be, either forward reaction increases, or if it is decreased, the reverse one. But it will, what you have to clearly state is that that will only be for a short time till the reaction readjusts itself and equilibrium status is readjusted. But provided if the temperature is changed, then there is going to be a permanent change to the equilibrium. A permanent change depending whether it's an exothermic or an endothermic reaction. So if you are going to change the temperature in which the reaction is happening, if it's an exothermic, if you have increased the temperature, then your equilibrium constant decreases. If you have decreased the temperature, then the equilibrium constant increases. In an endothermic reaction, that is when you're supplying heat energy for the reaction to take place, and the system in which the reaction is happening, if you have increased the temperature in which the reaction is happening, then if the temperature increases, your equilibrium constant increases. If your temperature decreases, your equilibrium constant increases. This is only for an endothermic reaction. And this only happens if the temperature is changed. For pressure and concentration, there is only a momentary change, but till the system can readjust and reestablish the equilibrium. So you have to follow the same, the 6 steps to get your full excellence in an equilibrium equation. Now, this as just in terms, these are the things you need to, and this is now the Chatlist principle is telling about the equilibrium and what changes happen to when you are changing the concentration, what is a change in conditions, and what happens to the direction in which the equilibrium happens. So what happens? But remember, all this will only happen if, and this things change only for a very, very short time till the system can readjust and the balance is brought forward or equilibrium is established. Now here, see, as I mentioned earlier, the increase and decrease depends on the endothermic or exothermic reaction. And that is what you have to be very careful while writing. if a catalyst is added, there is no change to the equilibrium position or to the equilibrium constant. Only thing is that it is reached much more quickly, that is the reaction rate changes. Now coming to the pH and conductivity questions. Now, pH you have learned last year. What is a pH and how is it related to your acids and bases? We know that lower the pH, then stronger the acid, higher the pH, it is a base. Now you need to know what is the difference between an acid and a base. Now acids are what we call as a proton donate. It donates protons, and bases are one which accept a proton easily. When you talk of those things, if it is a strong base, then it easily accepts a proton. If it's a strong acid, it easily donates a proton. That is what is by definition the pH is. So, and we also know that acids and bases always react to give you a salt and water, and that is the neutralization reaction which you have learned. The steps to follow in this is looking. Now, if it can totally dissociate, yes, it will form. It can conduct. If it doesn't, if it's a partial one, the conductivity will be low. So this is what you have to write in your answers. Now, when we are talking of proton donators, when we see the hydronium ions, that means it is an acid. OH or a hydroxide ion, it is a base. This is what we are linking the ions to the base and the acid. This summary helps you a lot, and this again is courtesy to the GIZ Science where I've taken this slide from. So you can go and look at what is a strong acid, what is a weak acid, what is an acid salt. And when it is completely dissolving, see that there is a high conductivity. If it is partially dissolving or dissociating, and then you have a low conductivity, and if it's a complete, you again have a high conductivity. So this is what we talk about: strong acids, weak acids, and acid salts. And the last part which I would go into is here. This is talking about the bases. If it's a strong base, yes, high conductivity. If it's a partial, same thing as the acids, low conductivity, and base salts, it will give you high conductivity. This were the key to your questions. Now, what I have not added here is the calculation of pH. I will add a new slide instantly to it and look at the pH. Just give me a moment. So what does a pH stand for? pH stands for the concentration of H3O plus ions, that is the hydronium ions. And if the concentration of those is, if the concentration of the hydronium ion increases, the pH goes lower. That means it's an acid. So if this is going, if the concentration is higher, the pH is lower and therefore an acid. Because we know that pH of an acid is 1 to 5, 1 to 2 being strong, and higher pH means weak acid. And so when you're calculating the pH, So to calculate a pH, what you do is, just a second. pH is negative log of hydronium ions. So if, once again I repeat, if the concentration of hydronium ion decreases, pH increases, that means it is a base. The other way around, if the concentration of hydronium ion increases, the pH is lower and therefore it is a acid. So this is the way you do it, but I'll share one more screen with you. Just a minute. Sorry, just a minute. Here, this is the summary of the pH formula, how to calculate. See here. So on the calculator, you see your negative sign, you have your log, put the value, and that's it to calculate the pH. Now, what does Kw stand for? Kw stands for ionic product, and that is, so the triangle tells you the ionic product is the concentration of your hydronium ions times the concentration of the OH negative. Now, normally this is given to you this year. You do not have to calculate the ionic product. This is 1 into 10 to the power of negative 14. This is always given to you in the exam. So given that you know your triangle, that if you're given the ionic product, you have to calculate the concentration of hydronium. So ionic product divided by the concentration of OH. Or if you have to calculate the OH, it is the ionic product divided by the hydronium product. So this is how you calculate. And then you also have using this to calculate the acid. So here it is to calculate the pH, whatever the number is given, that is 10 to the power of that. So how do you use it to find the concentration? Look at it, shift button, 10 to the power of whatever you have, and the negative sign. So if you have, and that tells you the 10 negative sign and the pH number, this is how you calculate the concentration in the other way around. Once again, I repeat, if you have to given the concentration, given the pH value, you have to calculate the concentration of hydronium ions, use your shift button, exponential button, your negative sign, and then your pH value. That gives you the concentration of OH. Calculating the OH, if you are given hydronium ions, then obviously you are calculating your OH. So cover your OH, Kw divided by your concentration. These are the key things for you to remember in your exam. But remembering that the formulas are given to you, you just need to apply them. But they won't give you it in a triangle form, but rest. And also the Kw is given to you in your resource sheet. And that was the end of this presentation. Any questions? Keep asking.
Thank you so much, Sujata. Afia is asking, so she says that she's kind of confused on how do you know if the reverse or forward reaction is favored? So how do you know when if the forward or reverse reaction is favored?
Okay, that depends on your Kc value. So as I'll go back to my earlier slide, I'll tell you just a moment. Give me a second. I'll show you the slide. So, no, not the slide. Just give me a second. See that? This is what tells you. The Chatlist principle is used to which.
I'm not sure if we're seeing the. Which screen should we be seeing, Sujata?
It's okay.
Is it the one with the triangle?
No.
No.
Are you seeing the triangle?
You might need to stop share and then share again with the new screen.
Okay, I'll do that. Yeah, this is the thing you have to use to understand which direction of the is favored for your reaction. So it depends on the conditions. So if the concentration, if there's an increase in products, so the direction, it is the reverse direction which is favored. If there is a decrease in products, it is a forward direction which is favored. Again, increase in the reactants, forward direction, decrease reactants, reverse direction. This chart tells you how depending. Now remember that the which whether the forward or the reverse direction the is favored depends on the conditions. If the condition changes, the direction which is favored changes. So that's what you have to remember. And that is only for, it's again remembering that this is for or a short time, that is with respect to concentration or pressure. But if the temperature is changed, increase or decrease, depending on the endothermic or exothermic, your directions will change, what is favored. So if we know that that's where I said, if in an exothermic, now if the Kc decreases, that means you know that if the Kc value is less than 1 in this reaction, then we will follow this process. That means it is the more reactants and it will be in the forward direction. But if it is more products, it is in the reverse direction. That's what you have to very, very particular, and this is only for the temperature. And again, the temperature increase or decrease of temperature, you have to look at what is the enthalpy of the reaction, whether it is an exothermic or whether it is an endothermic reaction. Have I answered your query?
Yes, Afia says, thank you for answering the question. It makes a lot of sense now. Afia did ask another question, but I think you might have covered that. The question was, how do you know if the equilibrium is going to the left or right of the equation? Like, what's the best way to know?
Yeah, that again, that is the key for that is your equilibrium constant, whether it is going in the forward or in the reverse direction. And as I told you, you don't have to worry whether it is a double arrow or a single arrow because it will tell you. It will always tell you is it a single direction one or is it a continuous process. So if it is continuous, remember it is a double arrow. If it is a single process, okay, the reactance happens and the product is formed, it's a single arrow, the reaction has ended. But if it's an ongoing one, then yes, you have to do. It will be stated to you. There is no guesswork for you at this level. Any other questions?
No, that's everything, Sujata. That was very thorough and a wonderful presentation again. Thank you so much for your time and for sharing your expertise with us. Really appreciate it. And I think you've earned a chance to go and put your feet up.
Yeah, and I will share this so that the students can have a look at it.
That would be much appreciated, yeah. Awesome. Thank you very much, Sujata. And thank you everyone who was watching just now. And hopefully some people will be getting benefit in the next few days leading up to the exam. All right. Have a great night, everyone. Ka kite.
Ka kite.